Good day, everyone. My name is JET SYEN, and I'm a final year student from Faculty of Electrical and Electronic Engineering of University Tun Hussein, Malaysia. The title of my study is Predicting Energy Production Trends in Malaysia, a forecasting study. This is the overview of my study. We start from the executive summary, methodology, result, and discussion, which include the stationary check until the conclusions, followed by the benefits of accurate forecast, acknowledgement, and finally is the reference of my study. So I would like to begin with the executive summary, or also known as the project overview. Malaysia energy production is crucial for the growth and meeting the needs of its population demand. Therefore, this study aimed to develop an accurate forecasting model by leveraging the time series analysis. And the result shows that the time series analysis is highly accurate in predicting the energy productions in Malaysia. The highest percentage of error is only 5.17%, and the lowest goes to 3.17%. Other than that, this study has provided insight into the energy production trends and strategy for sustainable energy, empowering the policymakers and also the energy planners and stakeholders to make the informed decisions. And this study is MOU with RS Energy STN PhD. Next, I would like to explain on the ARIMA. ARIMA is also known as the Autoregressive Integrated Moving Average Model. So first, I would like to explain on the autoregressive, which is the AR. Autoregressive is looking at the past value, and if you look at the ARIMA, there's a PDQ. P is the autoregressive order, and it considers the impact of the past P value on the current value. The next will be the integration. Integration is aimed to remove the seasonality or the trend of the data to make it stationary. Because in time series analysis, before we do with the forecasting, we have to make sure that the data is stationary. Then only we can use the time series analysis to forecast on the future data. So the MA is the moving average, and is the Q is the moving average order. It considers the impact of the past forecast area on the current value. This is the project flowchart of my study. First, we will begin by collecting data from Malaysia Energy Statistics Handbook 2021. And this is the latest handbook which provided the data of energy productions from 1990 to 2020. Next, we do plot the data of versus time and check the stationary by using the ADF test. ADF test is a statistical test which is known as the augmented Dicker-Fuller test, which used to check the stationarity of the data. This is important because we have to determine whether the data is stationary or not. Only the data is stationary, then we can proceed to choose the forecasting model because time series analysis requires that the data is stationary. So if the data is not stationary, we have to do the data transformations by differencing or detrending. Then we can proceed on our next step, which is to choose the forecasting model based on the SCF and PSCF functions. SCF is the autocorrelation functions, and PSCF is the partial autocorrelation function, which can help us to determine which model to choose. And next, we can start to build the selected forecasting model and predict the future value. Once we get the future value, we can start to evaluate the performance of model by using mean absolute percentage error. Once the error analysis is less than 10%, then we have to restart our building the forecasting model to make sure it is an accurate forecasting model. If it's less than 10%, then our model is considered as successful. This is this is from a previous research that is about a day ahead forecasting of the percentage renewable based on the time series statistical method. From this research, the author find that the author have achieved a mean absolute error rate of 6.76% to 11.57%. Now we are entering the result and discussions. So we will begin with the stationarity check of the data. The figure on left hand side in figure 2.0 shows the graph of energy productions versus time, which from 1990 to 2020 shows a clearly upward trend, while the figure on right hand side is the result of ADF test. The result of ADF test shows that the data is not stationary. Therefore, we have to do data transformation in order to make the data stationary. In this figure, it shows the comparison of the graph between the original data and different data that have undergone the data transformations. So the graph on the upper half is the origin data, and the graph on the below half is the different data that have undergone the data transformations. Before continue on this slide, I would like to explain that I have used three ARIMA model in this study. The first will be the ARIMA 111. So, and I have forecasted the value of the energy productions from 2021 to 2024. The value for 2020 is around 3,700 and the value in year 2024 is around 18,000. This is the second ARIMA model, which is the ARIMA 011. And it forecast also is also forecast for the next 4 years. So the value for the 2021 is around 1,000, while the value for 2024 is around 15,700. And this is the third ARIMA model, which shows in the figure 2.5, which is the ARIMA 212 forecast. And the value for 2021 is around 5,700, while for the year of 2024 is around 17,500. This is the performance evaluation on the three model. And in this figure, I use the year of 2017 to 2020 to determine the accuracy of model. But in my study, I have forecast the value for year 2021 to 2024. The reason why I use 2017 to 2020 is that I have used the mean absolute percentage error in my study, but it requires both the actual data and forecast data. So I decided to do the forecasting again for the year of 2017 to 2020, and then I get the forecast data, and original I have the actual data. Then I can do the mean absolute percentage error. So from the figure, you can see that the ARIMA 111 model has achieved the lowest average percentage error of 3.89% and is considered as the most accurate model among these three models. The conclusion from this study is the ARIMA 111 model is the most accurate model because it has achieved the lowest percentage error of 3.89%. And by doing the performance evaluations through the year 2017 to 2020, the mean absolute error is around 3.17 to 5.17% for the three ARIMA model. So the study concluded that time series analysis is highly accurate in predicting the energy production in Malaysia. There are a few benefits of the accurate forecast. First is a cost saving, second is the reliability, and third is the sustainability. From the term of cost saving, because we have optimized the energy productions planning, it leads to the reduced operational cost and a better resource allocations. And second, the reliability. The accurate forecasts have ensured the consistent and reliable energy supply, therefore meeting the customer demand in Malaysia. And lastly, the sustainability. The improved forecasting have enabled a better integration of renewable energy source and therefore it had reduced the environmental impact. This research is supported by University Tun Hussein on Malaysia UTHM through Tier 1 Grant Research Q352. Thank you for watching my video of presentation.